A very good morning to all speakers and participants from various part of the world. As we all know, we step up into this new year 2024. We would like to wish you all a very happy new year and extend our heartfelt wishes for a prosperous and fulfilling year ahead. I, Kirti,
I, Jatin,
research scholars from Department of Mathematics and Statistics, Central University of Punjab, welcome you all on the behalf of Central University of Punjab, Bathinda, India.
It's our privilege to hear among us this gathering of brilliant minds of individuals who have a deep enthusiasm for data science and scientific computing.
We welcome you all on the opening ceremony of this 2-week faculty development program on data science and scientific computing, jointly organized by Central University of Punjab, Bathinda, India, Poornima University, Jaipur, India, Nexus University, South Africa, Baba Farid College, Bathinda, India, Math Thinking Foundation, India.
This FDP focuses on empowering participants with the skills and knowledge needed to analyze complex data sets, apply algorithms, and leverage scientific computing tools for problem solving.
Now, to commence with this momentous occasion, we are honored to invite Dr. Manoj Gupta, Co-President from Poornima University, Jaipur, for delivering the opening address. Over to you, sir.
Thank you. Very good morning to all of you. All the dignitaries, particularly Dr. Mehar Chand, Dr. Javed, Dr. Sabarjeet, Dr. Swati Gokru and others, for giving me this opportunity to talk to you. Dr. Valentina also is there. So Happy New Year to all of you. And it is very important event, and the best part is that 5 organizations are coming together and bringing their expertise and candidates and students together on a single platform for this FDP. The topic is very apt, need not to tell how important it is. Data science and scientific computing, it is very important and very need of the hour. We need a lot of work to be done in this area. We have to build capacity of our own faculty members, because there are n number of subjects in almost every stream. You talk about engineering, management, architecture, everywhere you will find data is there, and faculty need to learn all those aspects which are related to data science and scientific computing. So it is very important topic, which is very much required for faculty members to learn. And I'm happy to see that a good number of experts who are having a lot of experience in this area, they will be taking sessions for faculty members and research scholars and participants. So I congratulate Dr. Mehar Chand for bringing all them together and organizing this FDP, which is very much futuristic and very much required at present. My best wishes to all of you. Thank you very much. Thank you.
Thank you, sir, for setting the tone for this incredible program. We now invite Dr. Javed Ahmed Khan, sir, Dean of Basic Sciences at Baba Farid College, Bathinda, India, to present the welcome address. Over to you, sir.
Thank you, Jatin. And okay, so as rightly said by Dr. Manoj Gupta, futuristic, and nothing is better than start the new year with this futuristic FDP. So Dr. Javed Ahmed Khan, Dean of Sciences from Baba Farid College, welcome you to this FDP, 14 days FDP program, and wish you a very happy new year. And as I said, starting is so it's a very good way to start to learn. And as all our professors here from a different streams, and I was very happy that the 5 institutions are combining together to launch this FDP program. So FDP, as we are not naive to the concept of faculty development program, so this is mandate by the UGC and the all governing agency of different countries that to update your information in certain areas. So in this direction, we have launched with the other institution to program, and Dr. Mehar Chand was very instrumental in bringing this. So once he started, thinking about this scientific computing and data sciences, so I was very happy to see that at least people are very keen to bring whatever knowledge they have and share with the other faculty member. So as I was saying that the FDP, the concept of FDP is important, but unfortunately, been in this area for last 20 years, worked in a different parts of country and in Europe also. So I was, sometime bit unhappy the way we treat FDP. I don't know if you agree with me or no. So we want that our students should be very attentive, very engaging in all our classes. But sometimes I feel very sad to see that in FDPs the attitude is same with the teacher also. So I hope this FDP will be very practical, and I can see the schedule is highly practical. And once you involve, once you start engaging the whole of your brain into the activity, you will learn, and it will not be boring. So I was telling that the concept of FDP is that a teacher, when he stops learning, is ceased to be teacher. So when you are not learning anything new, you don't have anything new to give to the students. And once you don't have anything new to student, which student cannot learn from the other sources, he ceases to stop be a part of your class. Normally, I was searching for a switch somewhere in our head that as you enter in a class, a student enter in a class, he switch off the brain. There's no switch actually, but they do that. All the senses you see that they will hear you and this thing. So engaging is not the especially after the COVID, the attention span is reduced. Unless you engage, you're lost. And then what a teacher is not entering a class. It's a machine or a robot is entering a class, delivering the 45 minutes of lecture, something, and come out. So for his, conscious, okay, I have completed the syllabus. But that's not the case. Unless we engage, the syllabus is not completed. He will not remember whatever you taught in a class. So unless you make them practice. And this FDP, as I can see that there are few very, highly eminent professors are there. Dr. D.K. Lobial, and I was reading Dr. Valentina article also in one of the newspaper also. She's very highly pioneer in this, and we're very fortunate. I'll congratulate all the coordinators and all the team that to bringing her on the dais, Professor Valentina, Dr. Pooja, Dr. Ibrahim Raza, Dr. Ajay, Dr. Amandeep, Dr. Harman Preet, Dr. Prayash, Dr. Ashok Kumar, Dr. Upender, Dr. Shalu, and Dr. Harish Kumar. So such an eminent faculty are a part of this program, and I'm very happy that the Baba Farid has associated with all these organization to bring this FDP into a new with the new year, and starting its new year with this approach. So I'll suggest, I will request all the speakers for today and the subsequent program, try to engage as was a part of a few FDPs also organized by the Baba Farid and MDTF and the other universities. The engagement is very high. But this engagement phase, another student participate. So I can see there are 105 participants. So I'll be very happy if you can type all the participants Happy New Year. So I can see that all of you are there with me. Happy New Year to all of you. This thing, just type a Happy New Year in your chat box, and I can see this. Okay. One. So I can see that you're still engaging because it's a journey, and an FDP or any event fail unless and until it's a collaboration. Learning is a collaborative project. It's not a one-sided project, which we mistaken. Same thing with the class also. A class is a collaborative work. between teacher and student. So learning is not the one way. We are not expert in any field. Being in neuroscience, working for last 25 years in this field, I can say I can know each and everything about brain. It's impossible. I know each and everything about brain, computing. Keep on learning. The computing is a new thing. Me, I recently learned Python and the other programming languages, few of them to be used in the data analysis and AI tools and clinical psychology. I recently finished my third master's. So these are the learning, I'm doing and try to engage class in that. So it's a collaborative, and I can see only 21 people have written, or 24, okay, have written. So that means only half people, not 1/4 people are still with me. So it's only starting. It's a welcome address only. So please, I'll request that, engagement should be 100%. Whatever, because it's a precious time, 11 to 1 every day for 14 days you are spending. Certificate you will get. That's not a thing. If you just switch off your brain and you listen to sir, you'll get a certificate. And there are many ways to get a certificate. That's not an issue. But unless until you learn, and that to learning doesn't stop with the FDP. Learning has to pass on to the student. And then your brain will work in that direction, and learning will be permanent. So, okay, there are a few more people have seen. So I hope all of you people who are still waking up from their home, and COVID has done a lot of hamper in our brain also. This effectivity there. We are so much used to listen to a system and then switch off, or you just switch off the screen and everything. So once again, I welcome all of you on board with this very good FDP program on data science and scientific computing. And as the last FDP also I said, please don't stop with this FDP. Means the learning should take it to the other. Since you're already meeting so many people, 109 people are there, and definitely there are certain people who will be interested to do a collaborative project with you or collaborative exercise. You visit the each other institute and try to interact with their student. And next time, I'm sure the Dr. Mehar Chand and the team and we will host this in a physical mode. And it will be much more learning when you physically see the speakers, interact with them. I request Dr. Professor Valentina, if we are be soon organizing an international conference, and we'll be very happy to have you here in India and in a physical mode. I'll deliver the lecture. So thank you very much for giving me an opportunity to be a part of this FDP. And Farid College is very happy, is always exciting and looking for new avenues and new teaching methodology. And thank you very much. Once again, a very prosperous and very highly learning Happy New Year. Thank you very much.
Thank you, sir, for such a kind and graceful words. It means a lot. Moving forward, now I request Ms. Muru Tola ma'am, President of Nexus University, South Africa, to provide a brief introduction of this remarkable event. Over to you, ma'am.
Madam, may I request you to kindly unmute?
Yes, ma'am.
Yes, President. Moratolo, please unmute your mic.
Yes, can everyone hear me? Good morning.
Good morning.
Thank you. Okay. Thank you so much for this wonderful opportunity. We are very humbled as South Africans. Lots of them, they came in through. I know it was, last minute for me to actually invite the participant, but everyone is so excited about this wonderful opportunity. And, Dr. Mehar, I just want to say thank you for this wonderful opportunity. All right, here we go. All right, dear esteemed participant, this is to our guests and respected colleagues. Greetings to everyone. I'm honored to extend my warmest welcome to each one of you, and this is on behalf of Nexus University. We are based in South Africa. As we embark on an enlightening journey through the 2-week faculty development program on data science and science computing, this collaborative effort, jointly organized by the Central University of Punjab, Bathinda in India, with Poornima University, Jaipur, based in India. And then we've also got Baba Farid College, Bathinda in India, and Math Tech Thinking Foundation, Vasilka, Punjab, also based in India. And yes, the collaboration also includes, Nexus University that's based in South Africa. This is a testament to the shared commitment of our institutions to foster excellence in education and research. Very short about the program, our data science and scientific computing workshop spanning will start from today, which is the 3rd of January, up until the 16th of January 2024. This is designed to equip participants with a profound understanding of data science concepts, scientific computing techniques, and their practical applications. Therefore, this intensive program will not only delve into fundamental principles, but will also provide hands-on experience through interactive sessions, like your coding exercises and real-world projects. This will also be covering a spectrum of topics, including your data manipulation, your visualization, statistical analysis, and advanced subjects, such as, your deep learning and cloud computing. Therefore, as collaboratives, we aim to provide a holistic and enriching learning experience. To our patrons, I would like to express, my gratitude to our esteemed patrons, which is Professor R.P. Tiwari, our Vice Chancellor of Central University of Punjab, Bathinda, based in India. And then we've also got Dr. Garmeet Singh Dhaliwal. He's the chairman of Baba Farid Group of Institutions, Bathinda in India. And then myself, which my name is Khomosa, as I've explained to you. I'm Khomoto Morotolo, president of the Nexus University based in South Africa. And last but not least, to mention Dr. Suresh Padi. He's the president of Poornima University, Rajasthan in India. Your visionary leadership and unwavering support has been instrumental in shaping the trajectory of this program. And we would like to send through our appreciation, and it goes to, all the conveners, the co-conveners, our coordinators, and all the organizing committee members who have dedicated their time, expertise to ensure the success of this wonderful, initiative. Their commitment reflects the collaborative spirit that binds our institutions together. And, in conclusion, as we embark on this educational endeavor, I encourage each and every participant to actively engage. Please, let's be very active, ask questions. If you don't understand anything, please don't be scared, don't be shy, just raise your hand. And then all our professors, our doctors, and all our trainers will be able to assist, collaborate, and make the most of this unique learning opportunity, a success. To everyone, may this program serve as a, catalyst for the exchange of ideas, fostering international partnerships, and contributing to the advancement of knowledge in the field of data science and scientific computing. Once again, to this transformative journey, I look forward to the insightful interactions and shared experiences over the next 2 weeks with every single one. I mean, this is a very, very nice opportunity. It's a brilliant opportunity. It warms my heart to see that, all these countries are coming together, and we actually have this common goal and this common vision. So from the side of Nexus University based in South Africa, as previously mentioned, my name is Khomotso Morotole, and I thank you very much. Thank you.
Thank you, ma'am, to insightful introduction. Now we would like to invite Dr. Deep Singh Sir, Head of Department of Mathematics and Statistics from Central University of Punjab, to brief this inaugural ceremony. Over to you, sir. Dr. Deep Singh sir, over to you.
Unmute.
Sir, you are not audible.
Sir, please unmute your mic. Your mic is not connected.
Okay. Am I audible now?
Yes, sir. Now audible.
Okay. Thank you, sir. Thank you, Jatinji, Kirtiji. Good morning and a very warm Happy New Year to all the respected participants, members of organizing committee and volunteers. On behalf of Department of Mathematics and Statistics, Central University of Punjab, Bathinda, and my own behalf, I welcome all the participants in this FDP and believe that this program on data science and scientific computing will be helpful to explore several dimensions of computing techniques. Data science is emerging area of computational sciences. We are thankful to all the resource persons and speakers for their acceptance and involvement in this exciting program. The program is being organized under the dynamic leadership and guidance of Honorable Vice Chancellor, Central University of Punjab, Professor R.P. Tiwari sir, Honorable Chairman, Farid Group of Institutions, Dr. Gurmeet Singh Dhaliwal sir, Honorable President, Nexus University South Africa, Ms. Khomotso Morotolo, and Honorable President, Poornima University Rajasthan, Dr. Suresh Padhi. We are thankful for their guidance and blessings to organize this program. Professor Javed Ahmed Khan sir and other speakers have already set the tone of the workshop and explained the significance of the program in a very concrete manner. So I will not take much time in that. I request all of you and expect active participation in all the sessions. Once again, I welcome you all in this program. And now I hand over the session to the person who is key person behind the program, Dr. Mehar Chand sir, the President of MTTF. Dr. Mehar Chand sir, please.
Thank you, dear Professor, and good morning, all of you, all the participants, all the organizing committee members, conveners, and all the speakers. First of all, congratulations to all the organizing committee members and the organizers who are behind this faculty development program and comes together to organize this wonderful workshop. There are many challenges. The participants who are registered in this faculty development program belong from different time zone all throughout the India, and some participants like UK and from India, there is big time difference from South Africa and India, big time difference. So there are so many challenges, and we tried to manage everything. We are communicating to each participant, and we are trying to reach every participant through WhatsApp, through email address, whatever, and each type of problems they are facing, we are trying to solve. And right now, in WhatsApp group, I saw in the before starting the session, there are 250 plus participants who are taking part in this activity. And right now, we have about 120 participants joined this program. But the more thing I want to expand here, because the participants are putting some queries. We organize this program in a very perfect manner. If some participant is not able to join due to some network problem or any other reason, all the things which will be presented in this program during 14 days will be recorded in the single platform. All the link through their email address, their WhatsApp number, we are sending regularly and will be provided. And along with there will be some assignments that will also be on this platform. And when you will access or log in your account, you will see all the things according to lecture wise and day wise recording, as well as the content which will be presented. And also along with we will assign some assignment or some recorded lecture will also be uploaded to make more successful this event and more valuable. So keep all these things note down. And still, if you have one more thing, we are sending emails, but sometimes the email go to in spam box. So I request to all the participants, please check your inbox as well as spam box, so that the email which we send, you can go through it. And along with there are so many instructions which we are sending through email address. So check regularly. This is very important to make this program successful and to get some knowledge and to engage all the faculty, all the participants regularly. And our team is behind there to accommodate to each participant to reach us. And we are trying to reach every participant whose contact number, WhatsApp number, and email address what we have. Okay, so in each media through these contact details, we are reaching to you. But sometimes some participants who are registered but not getting some information. So still we will try to engage everything. And I hope this event will be very successful to all the participants. And if any participant are getting any challenge, please don't hesitate, reach us, and our team will accommodate you to get everything. So now, before inviting our today's speaker, Professor Valentina A. Balas, I would like to introduce her. Professor Valentina A. Balas is currently an associate professor in the Department of Atomic and Applied Software at the Faculty of Engineering, University Aurel, Vlaicu, Arad, Romania. She holds a PhD in Applied Electronic and Communication from Polytechnic University of Timisoara. Since 2003, she is author of more than 140 research papers in refereed journals and international conferences. Her research interests are in intelligent systems, fuzzy control, soft computing, smart sensors, information fusion, modeling and simulation, electronics, measurement and system theory. She is editor-in-chief to International Journal of Advanced Intelligence Paradigm, member in editorial board for national and international journals, serves as reviewer for many international journals and conferences, and is evaluator expert for national and international projects. She participated in many international conferences as general chair, organizer, session chair, and member in the International Program Committee. She was mentor for many students' team in Microsoft, Google, and IEEE competitions in the last 6 years. Dr. Valentina Balas has a great experience in research projects. She is a member of EUSFLAT, ACM, and senior member IEEE, member in TC, Fuzzy System, IEEE, CIS, member in TC, Soft Computing, and also a member in IFAC and Computational Intelligence in Control. I hope her valuable thought in this lecture will be very highly informative, valuable to all the entire participant who are taking participate in this faculty development program. Now, I would like to welcome Professor Valentina A. Balas. Over to you, Professor Balas. You can unmute your mic and welcome in this session.
Thank you very much, dear colleague Mehar Chand, for this introduction. And first of all, good morning to all of you, and my best wishes for a happy new year also for all of you. I will try to introduce my presentation, and I would like also to express my appreciation to the organizing committee. There are 5 universities here that organize this wonderful faculty development program. I would like to extend my greetings to all participants here, and because I am the first speaker, I will only introduce in a few directions related to data science, and also I will continue with my research and my research team here in Arad, just to know maybe they are not exactly directed my research to data science, but we have a lot of links to data science, and we start to work in the last few years. So let me share my screen first of all. Yes, it's here. I also want to tell you that I visited your university, Bathinda, in Bathinda, Baba Farid University, in March 2019, and it was a very nice visit. I met there good professors that are my friends from that time. So the title of my presentation is general, as I told you, Artificial Intelligence and Machine Learning, an Introduction to Data Science. But as I told you, I will continue with few research that we develop along the years. First of all, just to see a few things about my country. So you can see Romania is located in southeastern Europe. Capital is Bucharest. And on the map, Arad, my city, it's here near Hungarian border, very near to the border. And Bucharest is 600 kilometers far from my city. Other 6 capitals are closer to Arad than Bucharest. So I studied in Timișoara, you can see very near, 45 kilometers far. And all this area over the mountain is called Transylvania. And my region, Arad, down to the Danube, it's called Banat region, and is the richest region in Romania with many different nationalities or multiculturality. It's here. You know, Transylvania is known as Dracula country, but not that castle near Brașov, it's Dracula castle, but in North Romania, it's located in that Roman. So a few images from my city. You can see the city hall, right side, the city hall, it's our university, the building where is our rector. You can see Mureș River, the second river in Romania, that is going around to an old fortress more than 300 years old. Here it's Cultural Palace, and here is the building of our university. before starting with the presentation, as I told you, it's a general presentation. I want to tell you that there are many other information that usually I'm introducing from the beginning. The most important is that we have a lot of memorandum of understanding with universities in India and around the world related to Erasmus project. Because we are working under Bologna system, professors and students from India and from other countries can visit Romania and can stay and study for 1 semester, even 2 semesters if they can stay, and professors as invited professor for 1 week or for 1 month. I also invite you all to apply and to have you here. Every year we have from India at least 2 professors and 1-2 students. Now we will start to speak about what is data science, and I want to tell you that there are many websites and a lot of documents and also many movies on internet that can explain very well all these terms. Also, I observe there are many books, e-books in India and everywhere that develop in the last years very nice this field. And I will try to explain you only few things. Maybe I will skip some slides because I put a lot of information here. So data science is a multidisciplinary field that combines mathematics and statistics, specialized programming, advanced analytics, artificial intelligence, and machine learning to transform raw numbers into actionable insights, empowering business decision-making, strategy, and scientific discovery. Data science analyzes large amount of data. This analysis help data scientists to ask and answer questions like what happened, why it happened, what will happen, and what can be done with the results. A lot of responses are here. Why is data science important now? Data science is important because it combines 2 methods and methodology and technology to generate meaning from data. Modern organizations are inundated with data. There is a proliferation of devices that can automatically collect and store information. Online systems and payment portal capture more data in the field of e-commerce, medicine, finance, and every other aspect of human life. We have text, audio, video, and image data available in vast quantities. We are inundated with data. This is the reality. History of data science. We will speak about this term when it appears and some other aspects related to the history. While the term data science is not new, the meaning and connotations have changed over time. The word first appeared in the 60s as an alternative name for statistics. In the late 90s, computer science professionals formalized the term. A proposed definition for data science saw it as a separate field with 3 aspects: data design, collection, and analysis. It still took another decade for the term to be used outside of academia. And the first person who used this term and introduced this term is John W. Tukey, one of the most influential statisticians of the last 50 years. it credited with developing the first data analysis techniques in 1962, allowing statisticians to form conclusions from partially flow data and data generation. As data generation continues to evolve in terms of speed, volume, and variety, modern data science require a robust technical skill set. John W. Tukey, one of the most influential statistician, also inventing the word software. He launched this word near hardware. He said at a moment that many years ago that software will become as important as hardware. While working at Bell Laboratories, the same statistician coined the term bit. So he introduced binary digit that describe 1 and 0 for basis computer programs. And along with other scientists, the same statistician developed the well-known fast Fourier transform. So he introduced a lot of new terms and research for statisticians, for engineers, and for all. Future of data science. Artificial intelligence and machine learning innovations have made data processing faster and more efficient. Industry demand has created an ecosystem of courses, degrees, and job positions within the field of data science. Nowadays, in industry, we need a lot of responses to what they need, and it's a big need for such specialists. Because of the cross-functional skill set and expertise required, data science shows strong projected growth over the coming decade. Now we have what is also important for us, and 4 things that are very important for data science. So as I said, I will not insist to all these texts you will have, because I will give you this information. So what we are looking for, these 4 descriptions are descriptive analysis. So descriptive analysis examine data to gain insight into what happened or what is happening in the data environment. We can visualize using some graph, line, chart, table, and other objects. Also, we have diagnostic analysis, is a deep dive or detailed data examination to understand why something is happening. Then we have predictive analysis, that is another important thing. This predictive analysis uses historical data to make accurate forecasts. And in the 4th line, we have prescriptive analysis that takes predictive data to the next level. Why we are using, and it's useful, data science for business. Data science is revolutionizing the way companies operate. Many businesses, regardless of size, need a robust data science strategy to drive growth and maintain a competitive edge. Some key benefits include discover unknown transformative patterns, innovative new products and solutions, and real-time optimization. It's very challenging for businesses, especially large-scale in enterprises, to respond changing condition in real time. This is very important nowadays. This can use significant losses of or disruptions business activity. Data science can help companies predict change and react optimally to different circumstances. Now, which are some business problem typically in the data science process? We observe these letters using OSM data science process. So all these letters means some important activities. So for O, obtain data. Data can be pre-existing, newly acquired, or data repository downloadable from internet. Data scientists can extract data from internal or external databases, company, CRM software, web server logs, social media, or purchase from trusted third sources. S means scrub data. Data scrubbing or data cleaning in the process of standardization the data according to the predetermined format. It includes handling missing data, fixing data errors, and removing any data outliers. Some examples can be changing all date values to a common standard format, or fixing spelling mistakes, fixing mathematical inaccuracies, and so on. E means explore data. Data exploration is preliminary data analysis that is used for planning further data modeling strategies. M is coming from model data. Software and machine learning algorithms are used to gain deeper insight, predict outcomes, and prescribe the best course on action. Machine learning techniques like association, classification, and clustering are applied to the training data set. N is coming from interpret results. So data scientists work together with analysts and business to convert data insight into action. They make diagrams, graphs, and charts to represent trends and prediction. Data summarization helps stakeholders understand and implement results effectively. So, which are the techniques that we are using in data science? These are the main top techniques that data scientists are using. So first is classification, then regression, clustering, and the basic principle behind data science techniques. Coming back, classification is the sorting of data into specific groups or categories. A regression is the method of finding a relationship between two seemingly unrelated data points. Clustering is the method of grouping closely related data together to look for patterns and anomalies. The basic principle behind data science techniques we can discuss here about while the details vary, the underlying principle behind these techniques can be teach a machine how to sort data based on known data set, give unknown data to the machine and allow the device to sort the data set independently, allow for result inaccuracy and handle the probability factor of the result. Now the data science practitioners work with complex technologies such as, mainly are these four technologies: artificial intelligence, that means machine learning models and related software that are used for predictive and prescriptive analysis. Then cloud computing, that is a technology that have given data scientists the flexibility and processing power required for advanced data analytics. Then in the third line, Internet of Things, that refer to various devices that can automatically connect to the internet. These devices collect data from data science initiatives. They generate massive data which can be used for data mining and data extraction. And quantum computing, that means that quantum computer can perform complex calculations at high speed. Skilled data scientists use them for build complex quantitative algorithms. So this technology is very much important to have high speed for all computing. How is related data science with other data field? Data science is an all-encompassing term for other data-related roles and field. What is the difference between data science and data analytics? Then we can discuss what is the difference between data science and business analytics. So there are some analyses introduced here. So while the terms may be used interchangeably, data analytics is a subset of data science. Data science is important field that has a subfield as data analytics. Data science is an umbrella term for all aspects of data processing. What is the difference between data science and business analytics? While there is an overlap between data science and business analytics, the key difference is to use technology in each field. Data scientists work more closely with data technology than business analytics. Business analytics bridge the gap between business and IT. They define business cases, collect information from stakeholders, and validate solutions. So data scientists, on the other hand, use technology that work with business data. And what is the difference between data science and data engineering? So you observe that are these three important things. So data science, data analytics, business analytics, and data engineering. Data engineering build and maintain the systems that allow data scientists to access and interpret data. They work more closely with underlying technology than a data scientist. So we have data engineering now. What is the difference between data science and machine learning? Machine learning is the science of training machines to analyze and learn from data the way humans are acting. It is one of the methods used in data science projects to gain automated insight from data. What is the difference between data science and statistics? Statistics is a mathematically based field that seeks to collect and interpret quantitative data. In contrast, data science is a multidisciplinary field that uses scientific methods, process, and systems to extract knowledge from data in various forms. Data scientists use methods from many disciplines, including statistics. However, the field differ in their process and the problems they study. What are different data science tools? Different tools used by data science are data storage, machine learning, and analytics. I will not detail all. And also a data scientist can use a range of different techniques, tools, and technologies as part of the data science process. Based on the problem, they pick the best combination for faster and more accurate result. A data scientist role and day-to-day work vary depending on the requirement of the organization. In smaller terms, a data scientist may wear several hats. Based on experience, skills, and educational background, they may perform multiple roles or overlapping roles. In this case, their daily responsibility might include engineering, analysis, and machine learning, along with core data science methodologies. Now, which are the problems that data scientists faced? Important things because for multiple data sources, different types of apps and tools generate data in various formats. Data scientists have to clean and prepare data to make it consistent. This can be also time-consuming, this activity. The next one, understanding the business problem. Data scientists have to work with multiple stakeholders and business managers to define the problem to be solved. This can be challenging, especially in large companies with multiple teams that have varying requirements. And the third, elimination of bias. Machine learning tools are not completely accurate, and some uncertainties or bias can exist as a result. Biases are imbalanced in the training data or prediction behavior of the model across different groups, such as age or income bracket. So this problem must be also solved. A data scientist must be able to do some important things. Let's see in this slide. So a data scientist must know enough about the business to ask pertinent questions and identify business main point. Then he must apply statistics and computer science along with businesses acumen to data analysis. In the third line, use a wide range of tools and techniques for preparing and extracting data. Everything from databases and SQL to data mining to data integration methods. Then he must extract insight from big data, predictive analytics and artificial intelligence, including machine learning models, natural language processing, and deep learning. He must also write programs that automate data processing and calculation. He must tell stories that clearly convey the meaning of the results to decision makers and stakeholders at every level of technical understanding. He must explain how the results can be used to solve business problems. He must collaborate with other data science team members, such as data and business analysts, IT architects, data engineers, and application developers. These skills are in high demand, and as a result, many individuals that are breaking into a science career explore a variety of data science programs, such as certification programs, data science courses, and degree programs offered by educational institutions. So it's very hard to acquire all these skills, and mostly a data scientist must work with other categories of scientists to put all information together. It's not an easy task to do all these things. So now, which are the tools that data scientists are using? Data scientists rely on a popular programming language to conduct exploratory data analysis and statistical regression. There are some open source tools support pre-built statistical modeling, machine learning, and graphics capabilities. Some languages include the following: RStudio, Python, and Python also include numerous libraries. Also, to facilitate sharing code and other information, data scientists may use GitHub and Jupyter notebooks. I saw that you will have in the next lessons. Also, some data scientists may prefer a user interface, and two common enterprise tools for statistical analysis include SAS, a comprehensive tool suite including visualization and interactive dashboards for analyzing reports, data mining, and predictive modeling. Also is important, speaking from the point of view of IBM, some information I took from their website, IBM SPSS, that is very important for statistics side. So there are many tools that I put here in this slide. And from IBM side, you can discover, you can use for free. And for building machine learning, data scientists frequently use frameworks like TensorFlow, MXNet, and so on. So there are a lot of tools and a lot of investment to teach data scientists to arrive to very good skills in this direction. Here are the data cycle that were introduced at UC Berkeley, can be seen in this figure. So first is capture. You must go in this direction: capture, maintain, process, then analyze and communicate. So doing this circle here. So capture, we need data acquisition, data entry, signal reception, data extraction. For maintain, data warehousing, data cleansing, data staging, data processing, data architecture, then process, data mining, clustering, data modeling, data summarization. For analyze, exploratory, predictive analysis, regression, text mining, qualitative analysis, and for communicate, data reporting, data visualization, business intelligence, decision making. So all these important aspects must be taken into account to see the cycle for data analysis. Data scientists' jobs are particularly relevant in the following industry. As my colleagues mentioned in the beginning of this program, it's a big demand for such specialists. Here are only few industries: so automotive, aerospace, supply chain and transport, aviation, travel and tourism, chemistry, consumer, energy, utilities and technologies, financial services and investors, global health and healthcare, information and communication technology, infrastructure, mining and metals, oil and gas professional services. So quite all fields need such specialists. This picture present Hal Varian, chief economist at Google and UC Berkeley professor of information science, business, and economics. He said the ability to take data, to be able to understand it, to process it, to extract value from it, to visualize it, to communicate it, that's going to be a hugely important skill in the next decade. We just arrived here. And such specialists, if you can obtain in your universities, and if students present here in this course can acquire and can work on project, they will be very useful for all these economical sectors. Which are the steps that are important to become a data scientist? Here are 3 steps. So first, earn a bachelor degree in IT, computer science, mathematics, physics, or another related field. Second, earn a master degree in data science or related field. And 3, gain experience in a field of interest. Today, data rules the world. This is the reality. This has resulted in a huge demand for data scientists, and data scientists help companies with data-driven decisions to make their business better. Overall, data science is changing the world for the better. Discussing about these 3 steps, sometimes if skills are very good, is not necessary the first step. If you have a good knowledge in another field, but you earn a master degree specialized in this direction, you can become a good data scientist for sure. Now, I want to introduce you some of my direction of studying. So it's about this paper that appeared just recently. It's one of my PhD students from Rwanda University, the Excellence Center of IoT in Kigali. It's about Claudia Abineza. 2 weeks ago, I was there in Kigali, and she has defended her PhD degree. This paper, it's a paper appearing in a Romanian journal, Studies in Informatics and Control, and you can see the title, Deep Learning Model for Early Subsequent Exacerbation Prediction. So COPID means chronic obstructive pulmonary disease. So we use some deep learning models to have such prediction. We are doing such data science here, and Claudia also prepare other papers in other ICI journals, and I supervise her as a main supervisor. The other supervisor was Professor Philibert from Kigali, the same Center of Excellence. So she published also in Journal of Intelligent and Fuzzy Systems and in some in international conferences. This is a problem that was proposed to us just last week from a company side. It is true, it's a kind of optimization and decision-making problem because now companies need to optimize their activities. It's about a shop, how to arrange all data. You can have the problem here, you will have it. We also are studying. There are few data introduced here. So in a big shop, how to organize activities, having in mind that there are different activities, there are some constraints, and people are working part-time, full-time, and so on. And skills also are different for each person. So how to organize the work there and to maximize the efficiency in these shops. Then I have also, with another PhD student in Romania, we started to introduce some automated decision making using artificial intelligence in quality engineering within the automotive industry. In Timișoara, it's a big company, you know, that the center is in Germany, so it's continental, and they have this continental in Timișoara with 10,000 people. And this PhD student that started just 2 months ago to automatize this process. She's working in quality engineering. How to do, because nowadays they are using their specific norms in automotive, and they are using only Excel. And not all data can be introduced there and to obtain immediately the situation of the company. So in order to reduce the non-productive time spent with the manual analysis of the data and to eliminate the human errors, the automation of the decision-making data analysis is vital. We started, and you can see here in this figure first upper side structure of the extraction from SAP system that nowadays they are performing, and they are using Weibull analysis, some statistical data taken from Excel. There are in this figure, and in this last figure down, she proposed automated decision using artificial intelligence and mainly deep learning. So she introduced, you can see internal data, big data. We are speaking about the big data always. They collect a lot of data, and automation of data, data modeling, it's very important, and data prediction. After that, generate reports automatically. First, it was presented data. They are doing just nowadays manually these things, and they ask to my PhD to try to organize and to introduce this digitalization in the company. It's very hard, and I cannot believe they have no such specialists. But it's not easy, and you need to organize such courses and to teach them and to introduce many people in this direction, not only one or two. Then I want to tell you that I discovered this book because I am working mainly in fuzzy. And I discovered this book written last year, Fuzzy Computing in Data Science, and I recommend you to see. There are nice chapters that have fuzzy inside to organize decision-making process and some fuzzy C-means, so clustering and things like this. There are interesting chapters with very well-known technologies using fuzzy. Now, I hope I have some time just to introduce my research in Arad, in my university, and also together with my team. I think I have only maybe 15 minutes or 45 minutes. 45 minutes I have, yes? So, this is my presentation where you can find some tools that can be used very easy even in your research related to data science. So I have an introduction, some methodologies that we are using, some specific controllers and different applications for switching controllers and for other applications for transportation systems or for greenhouses. And some conclusions. So what is interesting? We have been influences here in Europe by these two important people coming from Greece and from Roman society, in ancient society. So the Greeks studied theoretical sciences and mathematics, among other things, writing theorem and proof of mathematical laws. And it's important to observe that Greeks valued knowledge for its own sake beyond just its practical applications. And the Romans research focused primarily on practical applications. And they are very, very well known Romans that are good in engineering, in architecture, and we know Roman arch roads and aqueducts. They are known for their well-designed durability. Even nowadays, we can see such structures. And usually we are using linear interpolation all around us. It's a basic reasoning technique. Anyway, using polynomial spline or other kind of interpolation is not bringing significant advantages, and also there are some costs. But comparing interpolative networks to neural networks, we can observe that interpolative networks are not suited for automate learning, but neural networks are suited for automate learning. Also, interpolative networks are not hiding information, neural networks are hiding it. So interpolative networks are capable to embed and process knowledge. We know that interpolative networks were introduced by Sir Isaac Newton and were considered as universal approximators. And speaking about fuzzy logic, introduced by Lotfi Zadeh, we observe that we are using knowledge linguistic representation. We are using computing with words. So fuzzy, it's a precise mathematics of imprecision. We are computing with words, but backside it's an important mathematics. The fuzzy interpolative methodology that we are using to develop some specific class to control intelligent systems, we developed along some good years, and we must know that such an interpolative controller, because we introduce interpolative networks, but now we are discussing about fuzzy interpolative controller. This is a fuzzy controller that can be equal with an interpolative network with linear interpolation, and each fuzzy control rule can have a corresponding interpolation node. And very easy, we can have this conclusion the linguistic fuzzy inference can be implemented by using lookup tables or other similar tools. Even we can use analog integrated circuits. So using MATLAB Simulink, we can have there such tools, lookup tables, and we can introduce a piece of knowledge there and to organize our controller. I don't know, I'm speaking now about these technologies related to fuzzy, but I think students and people involved in this course has some knowledges about fuzzy methodology and fuzzy logic, fuzzy controller, and so on. We have a derived concept, a fuzzy interpolative expert system, and all is going to developing in the next slide the fuzzy interpolative methodology. This is helping us to develop our controller. So in developing this methodology, fuzzy interpolative methodology, we use some technical support. In upper side of this slide, you can see Sugeno fuzzy controller. So we were inspired by the paper of Zadek, Sugeno, and Bauer. Such Sugeno fuzzy controllers can approximate any finite and dimensional function with arbitrary precision. So this black line is approximated using such interpolations. In this case, there are few rules. So red line is approximating the black line. If we put much more granulation, we will approximate to very close the black line. Second, we are using the linguistic design method, which through which any given transfer characteristics may be approximated by mean fuzzy controllers. And third time, we are using the paper of Cloxin Morgan and Laurent Foulois. That means the qualitative control method based on the real-time online qualitative analysis of the error phase trajectory. You will understand just following the next slides. It is true, it is about some specific information from system theory, from control systems, and so on, but it's not so hard to understand because you are also studying system theory. We were inspired, as I said, mainly from this last Cloxin Morgan Laurent Foulois. I visited Professor Laurent Foulois his university in Annecy, and you will see what means this qualitative control. So the main model is this Sugeno controller that is a linear combination of the input. So we will have an immediate linear interpolative equivalent. That means using of triangular fuzzy partition, prod sum inference, and center of gravity defuzzification. In fuzzy systems, we have the three important things, so fuzzification, inference, and defuzzification. Mainly, we are using MATLAB Simulink and mostly fuzzy toolbox in MATLAB, and there we can choose between these two kind of controllers, Mamdani and Sugeno. In Mamdani controllers, we are using fuzzy as input, fuzzy set as output. In Sugeno, we have fuzzy as input and a linear combination for output. So the fuzzification is different. Here is Professor Michio Sugeno in this picture. Unfortunately, he died last August. He visited us many times, like Professor Zadeh. They were our mentors. They visited Romania many times, and especially to my conference, Soft Computing and Applications. In closed-loop control application, fuzzy interpolative controllers are matching a fundamental time analyze tool. This phase trajectory of the error associated with the qualitative analyze. So here in this figure, you will understand the main tools. So fuzzy interpolative methodology tools. First, you can see that in controlling system, we are using this figure upper side. So the evolution of the error versus the derivative of the error. And usually we want to obtain the error zero between what we prescribe at the entrance of the system and what we obtain at the output. So the phase trajectory of the error is upper side. Then we have the McVicar-Vallon tables in second line. So we have here some numbers that have an important meaning in automatics. So numbers means rules that are going again to the center of this table where the error is zero. And the third line, we have the interpolative networks implemented in lookup tables. It's a tool that we can have in MATLAB. So we can have these two important points. We are using fuzzy set and logic theory that will be applied during the conception and development stages, and linear interpolation for implementation stage. So fuzzy for development, interpolation for implementation. There are also some important steps for each point that I described earlier. For A, I will not enumerate all, how we are building the control rules, how we design the Sugiano controller, and for B, we designed the lookup table with linear interpolation. We have such simple controllers that can stand for the best control solution, but only if we provide with relevant knowledge about specific control process, and all is about the control theory. And this knowledge becomes compatible with controllers if it can be modeled. And models can be used either directly as internal models we are using in our applications. Quite in all applications, internal model, we need to have a precise mathematical model, and that can be included in the control algorithm also, or we can indirectly by assisting the design. And if we have such a precise idea about how we want the system to perform, we can design such planned control systems. And the lookup table techniques permit us to introduce this element of incipient world knowledge, as Lotfi Zadeh named. So we have world knowledge as specialists in a field, and we can use that world knowledge as experts. Now you can see very fast the members of this family of controllers that we develop. First, it's a controller that is plane surface adaptive interpolative controller, then it's fuzzy self-adaptive interpolative controller, and last one is fusion fuzzy self-adaptive interpolative controller. So each family is working better than the previous one. Some simulations. First of all, the first member of the family, his structure is here. So we have a 3D lookup table, you can see here, and the central controller, it's a PD, proportional derivative one, and the other two organizing the 3D lookup table have the same numbers in the lookup table, only the central point are different. So we are introducing near the error and the derivative of the error, the integral of the error. So qualitative control when the integral of the error is positive or negative. So such a structure of the second member of the family, fuzzy self-adaptive interpolative controller structure, it's in this figure, is organized around the first member of the family and also introducing an estimator of the state, an adaptive fuzzy interpolative corrector, and of course the plan that we want to control. And here are some simulations, and for a normal PID controller, we can see here an overshooting, and for fuzzy self-adaptive interpolative, the step response. So we offer step response at the entrance, and we want to obtain the response at the end. It's a third order system here. The response is much better for this fuzzy self-adaptive interpolative controller. So this controller allows the control of the overshooting. There are some linguistic rules, but what is also important here is related to 4 categories according to the operating regimes. So such a controller is operating in stationary, transitory, oscillatory, and unstable. We will recognize in the next figure all these kind of operating regimes. Such operating regimes may be identified online in real time by qualitative analysis of the phase trajectory with the help of such fuzzy interpolative controller. And we group all possible operating regime in these 4 clusters, and thinking to gain, discussing again about gain, we have these 4 clusters. So G1, G2, G3, G4, that means G1 steady, G2 oscillating, G1 transitory, G2 steady, G3 oscillating, G4 unstable. So we have here 3 operating regimes, G2 that show us that in this graphic the error versus the derivative of the error is going to 0, so it's a good system. G3 show us an oscillating system. We try to eliminate oscillations or to have them very small, and G4 it's unstable, so the error and the derivative of the error are going to infinite. And here we have a table where we put the error and the derivative of the error in this table, all related to such rules. And we can observe this kind of regimes. So we have mainly G1, G2, G3. We don't have here unstable. So using and controlling by such rules, we can obtain a very robust system when we control it. Only using rules. For a third order system, we can observe for a PID controller. So we obtain large oscillation. For a fuzzy self-adaptive interpolative controller, we have small oscillations. So it's good, this second member of the family, small oscillations. We cannot eliminate completely because the system is like here, third order system. Here it's the last member of the family, fuzzy fusion self-adaptive interpolative controller, and we build in MATLAB Simulink these blocks, and we control a second order process. We introduce saturations, we introduce also PID at the entrance, and of course, an imposed value. We also introduce a dead time. You know that quite all process around us that we want to control are highly nonlinear with dead time, and there are hard conditions. In reality, we are doing some simplification and introducing linear control, but as I told you, quite all are non-linear systems. And how to control and to obtain good results. Here it's about this third member of the family, fuzzy fusion self-adaptive interpolative controller, how is working on different plants. We have a second order system with dead time, a third order system with dead time. For third order system, we have some larger oscillations. For second order, some overshooting, but even hard conditions, our controller can control the process. Now, there are some important applications where we apply such controllers for air conditioning equipment of uncompartmented passenger railway coaches, because we have here in Arad the biggest factory for railway coaches in southeastern Europe. And we were working there for 9 years. So we applied for some process that we know very well. This is one process, and another one is for an ABS braking. And for the first system, it was permitted to reject the oscillations caused by dead times. So dead times introduce, as you saw, some oscillations we can reject. Also for ABS braking, for railway coaches, we will have precise control action, and if these actions are robust against adherence perturbation, and there are no shocks or oscillations. We know that for railway coaches, we need to have a comfortable traveling with no shocks and such oscillations eliminated. So comfortable will be there. Here, it's an application, a simulation for such a controller without adaptation and the same with auto-adaptation, even introducing some facilities and blocks. We can see some small oscillations, and here oscillations are not there. Here it's the power, but here again, we can see oscillations looking in state space, large oscillations, and here very small oscillations. So using same controller with auto-adaptation. Here it's for an ABS braking system. Red line is the speed of the car, and blue line is the speed of the wheel and during the braking process. And the speed are not the same, but for precise braking force, we need the information, always to have the information for the speed of the car, but we have only blue line, this information that we collect from the sensors of the wheels. And also, if we will have an adherence perturbation, we can eliminate, here it's a perturbation, and here we eliminate this perturbation. You can see a small difference. There are some advantages of such controllers. Very fast and easy to develop, various adjustment oriented to diverse objective. We can cope with unknown process, the phase trajectory of the error constituting an observer of the system, and we can also introduce expert knowledge. There are efficient implementation, very fast and very easy, and also possibilities of hardware implementation, because we can develop in theory such things. You saw a lot of simulations, but how to do in a real process. For real process, we first introduce some precise mathematical models of the railway coach. So we need such scientific computing to do here along all our research. And the computer model is very important in our controlling process, because we will compare always the result obtained from the computer model with the reality. And the computer model is very near to the reality, then it means we are controlling well that process. And I also said that simulations is okay, but we need to apply everything. And for this reason, we need hardware. And as hardware, we resolve immediately the problem using FPGA board. So we implemented this algorithm, in fact, for fuzzy interpolative controllers in such Altera board that it's a FPGA circuit. So very easy, you can program and you can have introduced your application. I also propose to many students to use our own controller to control their process. They develop different process like power electronics, power system grids, and medical applications, how to control an artificial pancreas and so on. And comparing with pure mathematics used in conventional automatics, these fuzzy interpolative controllers are working better. And even the process are highly nonlinear and very complex. Here, it's about another application I will try to explain you faster. So here it's about the same process related to braking system. And we have the speed of the car and the speed obtained from the wheel, from transducers that are put on the wheel. And mainly we are using digital systems. Digital systems in competition with analog systems. But even using digital systems, we will observe that they have some limitations. So you can see here a lot of how to say changing of the data. This red line, it's going up and down because of digital systems. So we will observe there are some switching controller instability. If you want to switch from a controller to another controller, let's say from automat to manual, system, we will find some interesting effects. So switching between automatic pilot to manual pilot, it happens, fatal airplane crashes, it happens. Same process happened in nuclear plants to Chernobyl, just changing from manual to automatic system. So digital algorithms need a perfect state initialization for the moment of the switching, when you switch from a controller to another controller. This is an application where we introduce again our controllers. So what we observe? So the switching system can be potentially destabilized by unlucky choice of the switching moment for Hurwitz stable closed loop system, and the concrete implementation of the computer that perform the simulation can produce the same effect. So some integration methods and tuning sampling rate that we are using in MATLAB Simulink, different integration methods, can provoke such problems. And what is very important, the frequency analysis cannot be used because transfer functions are defined for null initial conditions, or we will not have null initial conditions. This is an idealization. We have initial conditions, and for this reason, we have such effects. A better solution to analyze is the time analysis. And again, we are using fuzzy interpolative expert system. I will go faster. So we have here in this simulation in MATLAB Simulink, two different controller, PI controller and a PD controller, up and down, and we want to switch from one to another one to control a DC drive. What is happening? There are different scenarios when we try to do this switching from one controller to another one at different moment of the time, we will obtain very strange situation. So switching from a PI controller to a PD controller, we are expecting to preserve the tendance, so to continue this line, but the attitude is the PD controller try to go up with this control output of the system. So the duration from 600 is going up, not maintaining the 600. When we start to have at 3 seconds, we switch the controller. When we try to switch to 5 seconds, is going down, and so on. So there are different directions, going up, going down. So it's a pure instability there. What to do? And we must, as I said, we need to maintain the initial conditions because having digital systems is happening like in this figure. So the aliasing effect caused by digital system. We can take a look on this chart, and on this one, digital systems create this illusion. It is happening the same in digital systems. So it appears this dangerous action. And we are using again the same controller, but we try to see the error between these two controllers. So the error is the difference between the output of two controllers that we try to switch from PI to PD. This is the evolution of the error. And again, when is recommended to have the switching action? Is not recommended to have it in the first quadrant and the third quadrant. You can see red color, but in the second and the fourth quadrant. Something it's happening in the sliding mode. Sliding mode, you can see the sliding contour. It's situated in the second and fourth quadrant. It's the same, the error and the derivative of the error. I think I have 8 minutes. And here it's an application for 2 airplanes. What is happening there? Pitch angle control. We obtain the transfer function of this airplane, and we introduce in this simulation again with switching from PD to PI. What is happening? Is happening again the switching moment, some oscillations, and is going in a direction. But if we switch at a certain time, output is going up, is going down, so instability. But if we choose the moment after some seconds, the trends will be preserved. And for another example, this airplane, we will obtain introducing in the as input this wave, we obtain some small oscillations, so it's working better. So what to do in this situation? The perfect for information transition, if we know the channel bandwidth, this is perfect for us. But one measure it in 3 minutes is not okay. What to do? We don't know the bandwidth of the system. And we will try to avoid first and third quadrant. And here is the figure that help us. So we have imposed value, the controller that is acting, and the switching to switch to the other controller. But we can see that the input of the second controller is always following, is a tracking controller, just to capture the initial condition, to have always the same initial conditions. And if we will switch from one to the other one, the process will be very well controlled. Here it's MATLAB Simulink and the simulation. So other applications are here, railway coach air conditioning. You can see in MATLAB Simulink the model that means a lot of differential equations transposed in these sub-blocks. And we have here simulations that we obtain. We put and we also verify with the real data from railway coaches from our factory. Here it's an ABS braking railway coach. Again, we have the model of the railway coach and what we are doing to obtain using these fuzzy interpretive controllers very good braking action. And here it's another application to the imposed braking distance. We need to stop at a certain distance from here. Otherwise, railway coach cannot circulate. So when they start to go in a course, first the locomotive is put to this condition to stop in a certain distance. Otherwise, they will not allow the locomotive to go out. So how we are doing this? Always collecting a lot of data and to produce this mapping, position, velocity. Again, big data and use them for our purpose. Other applications are for automat cruise control. I will tell you here this important theory that we introduce are nowadays used in automat control of an automobile. And it's about the time to collision criterion. It's here in this figure. It is very easy to understand formula, the distance versus the difference of the speed of the car 2 that is following the car 1. And this formula is not working well when the both speeds are same, because we will have infinite there. So we will inverse, and we will have the inverse time to collision. If you try to find our papers in the literature, you will find them and understand this criterion that was used nowadays very, very often. There are many citations, even from Renault company, someone working on an application for them to maintain the distance between cars inside cities. And we collect also a lot of data, and we maintain the distance using such algorithm. And using our criterion, it was obtained fuel gas economy of 35% inside city. Same criteria can be used outside for organizing a platoon and so on. Here is how is the evolution of time to collision and inverse time to collision, and how we can use this graphic for creating a fuzzy partition that can assist the driver. So this fuzzy partition, the green line means a safe situation, so you can preserve the trend. If you are in this red area, it's about compulsory hard braking. If it's in blue area, no risk at all, and you can have any kind of action permitted. Also, for a constant time to collision, we discover in the literature this formula. And this formula, we demonstrated that has some coefficients that has no meaning for people. And using our controllers, we can control, and you can organize such a following car and even a platoon very fast. You will see here in these simulations. So if we will preserve time to collision 4 seconds, 7 seconds, 10 seconds, we can organize such platoons and maintain the distance. For different speeds, you can see we can maintain which is the distance and how big is the time to collision. Here it's a tandem car 1 with car 2. And here in this figure, you can see that formula that was introduced empirically in many papers and used for automatic driving cars. So is going up and not maintaining the distance. Our criterion show how the cars can maintain the distance. I will go faster. I can see I have 1 minute. So here are simulations for such controllers. And last application is this greenhouse intelligent control using again fuzzy interpolation. And we can use to compensate some slow action, some predictive feature. We collect a lot of data, and we have in our database the data from a greenhouse in Toulon University in France, and we produce our own model of the greenhouse, and we try to control this greenhouse. There are different possibilities to control it, but using renewable energies, because we are using such greenhouses, and we are using sun, wind, and heat pump as possibilities, and we try to maintain the temperature inside the greenhouse. You can see the system, how it's developed again in the fuzzy toolbox, and how is the control surface. And here, if we use a system that is starting heating, how is consuming, but using fuzzy controllers, we save energy, about 23% of energy. And of course, we can use natural ventilation, shading of the plant, and again, such controllers. These kind of greenhouses are very cheap, using passive control actions. So we are using only renewable energies, helping each other during the day, during the night. And here you can see how is the temperature inside, how is the temperature outside, and how to maintain the temperature. So we don't want to have this greenhouse effect inside that permits to grow the temperature more than 30 degrees. It's not okay for plants. We need to keep in a certain domain. So here are some conclusions. Fuzzy interpolative is allowing such linguistic representation of knowledge, and we can use lookup tables. They are perfect matching for complementary techniques, and we are using qualitative analysis, phase trajectory. This method is versatile and efficient in application, and we developed in the last stage of our applications. We put greenhouses over the buildings, and we have intelligent rooftop greenhouses, but more we try to create a symbiosis between the greenhouse on the top of the building and the building. So we will extract oxygen from the greenhouse on the top of the building and introduce in the building, and from the building we introduce carbon dioxide in the greenhouse to be used by the plant. Other models, other computer models, other simulations, and collecting a lot of data to have a precise model to control and to predict what is happening there. So thank you very much for your attention. I hope it was useful, my presentation, even maybe a little bit complicated with this fuzzy sign and controllers, but I demonstrated that using fuzzy, we can develop in data science very nice systems that can be controlled, predict, and maintain in good results all our systems, but using intelligent techniques. Thank you very much once again.
Thank you, dear Professor, for your insightful, valuable lecture. First, we would like to open the session for discussion. Dear participant, you can unmute your mic. If you have any kind of query, question, please feel free to ask and discuss here. All the participants are permitted to unmute your mic. You can unmute and put your question, or yes.
Hello. Good afternoon, sir.
Good afternoon.
Good afternoon, sir. Sir, attendance, what about the attendance? We get a link or?
If you have any question related to this session, please ask. Rest all the information will be discussed later.
Okay, sir. Okay.
Any question, please, dear participant? Or either you can raise your hand.
Good morning, sir.
Yes, good morning.
Yes. I'd like to ask, will we be able to get the presentation because there's so much information that has been shared by the professor and someone needs to really process it in order maybe to be able to get some more clarity? And will we be able to also ask or maybe submit questions beyond this presentation?
Yes, we will provide all the content which is being presented here. If the participant have any question to discuss with today's keynote speaker, you can unmute your mic and put your question.
Okay, if not, I have one question, Professor Valentina. So my question to you that how this data, right? How this data can be converted or transformed into fuzzy?
So you need to know your data and then to organize fuzzification of your data. It's a process that permit you to introduce some fuzzy sets as granulation as you want, 3, 5, 7 usually, and to respect that orthogonal condition, so overlapping at 0.5, just to have a good control surface. So you
itself,
need
data is large, and if you convert it into a fuzzy version of it, like type 2 fuzzy or intuitionistic fuzzy or Pythagorean fuzzy, these are one data is specific into like 3 components. So it becomes more big data. So how that could be handled?
So you can introduce some domains, so very small, medium, and so on. And even you have a lot of data, you can introduce in an interval. As I said, computing with words. No, we have small, very small, medium, big, and very big. Let's say 5 different. And even you have a lot of data, you can introduce in an interval. In that interval, you will have concentrate a lot of data. This is the same at the input, and at the output, if you are working with Mamdani, you will have as output also such data. And for decision making, you have a lot of methods using fuzzy. So it's easy to organize and to have this. But this is my problem. I don't know which is your background, and for all students involved here in this course, if you have some small...
So my background is operation research. I'm an assistant professor in Jaipur University, Central University in Assam, India.
Mm-hmm.
And like I am applying this data science in supply chain. And also I work in fuzzy domain, like a few of my papers are in fuzzy inventory modeling. And
Yes.
this Poshundi Chatterjee is my co-author in one of our papers.
Okay. So you must read or you must write me and to continue discussion, because these are in general things that I introduce you and some of our applications very fast explained. So each application need to be explained in details. Is not
Right.
so easy. And even the methodology to understand. But as I recommended you that book, you can find even in that book only fuzzy in data science. So just to demonstrate that maybe you are thinking we are using neural networks and nowadays deep learning and only such tools. But no, fuzzy is also there. We can combine with deep learning. Why not? You know, there are fuzzy neural, genetical algorithm, and so on. So
Thank
there are.
you. Yes, actually, this is also new for me, that from your insights only I got to know that this fuzzy version of data science can be implemented in supply chains also. So hopefully we'll discuss this over
Yes,
email.
we
Thank you so
can
much.
discuss.
Dear Professor, there is one question in the chat box also. Maxulo Sele, you can unmute your mic to put your question.
Thank you so much, Professor, for the presentation. You're speaking to Sbongile from South Africa, and I was actually excited to hear that you can also be able to collect data on greenhouse gases that you're having. I'm doing farming on a rooftop in the inner city of Johannesburg, and I would like to know, going forward, if you want to collect that data of how much gases are we emitting from the rooftop tunnels that we're planting vegetables on, and how do we take the carbon back? So just as a way forward, if you could give us just a few steps of how we collect that data. Thank you.
Okay. We first use a lot of data from a greenhouse from Toulon University in France, because some members of my team were doing research there in some periods. So they recorded quite all data from inside and from outside. And I did not put in this presentation the model of the greenhouse, that is, I told you, a system of differential equations, mainly 3 different differential equations for the building, for the rooftop, and 3 differential equations for the building. And we try to put them together and to maintain even the temperature upper side, the temperature inside, and the oxygen and the carbon dioxide inside, and the building and inside the rooftop greenhouse. Of course, temperature outside. In this system, we also use heat pumps, because it's a more stable source for keeping a good temperature inside. So first, we use information from Toulon University. They gave us all their data, a lot of recording data. We put all data together and we organize the model, a very precise model, because we put the evolution of the temperature in a day, and then our model was following completely that model. Of course, we tune some coefficients in that model using genetical algorithms. During the evolution of the weather, there are also influence of the wind. We put also the influence of the wind. But for our studies nowadays, we purchased some sensors, you know, maybe about Planet Watch, and we organize a small model like a building and like a greenhouse, and we put these 2 kinds of sensors that measure the carbon dioxide and oxygen. We are interested in this. Why? Because having such a building with the rooftop greenhouse inside the cities, where we know the carbon dioxide can have a high level, as I saw in Delhi in November. Approaching to Delhi, it was a smoke, important smoke. I cannot even take a breath. So in the cities, carbon dioxide is very highest concentration, and putting such greenhouses on the buildings, we can produce oxygen and consume carbon dioxide from inside the building and even from outside, because the plant use this. And we are now collecting our own data, and this system can be seen. If you buy the system, you can see the concentration everywhere. There are some such sensors in the world, and you can see how is the situation. But as I told you, we are doing agriculture inside the city, and we are producing oxygen for our people inside the building. So if you are working in this area, you can find our papers. And recently I saw on MDPI another paper on the same field, using our results and also developing. But mainly, we were inspired by such a project from Barcelona. In 2014, they organized such a building, and they have laboratories there with plants measuring concentration of oxygen, of carbon dioxide, and this building, the first building in the world, was organized by Nexus company in New York. They put such a rooftop greenhouse on a building. So the cities in the future can have such greenhouses on the top of the buildings that can have or can produce vegetables, or can have a nice green area inside for people, and so on. All that buildings can be connected to Skyline City, so the future smart cities that can use as Internet of Things tool the weather prediction and how to do inside, how to have the values of these parameters inside the building, on the top of the building, and so on. So it's a future, and as I said earlier, we can help agriculture by producing our vegetables inside cities. I am happy you are working in this area, and I am interested in your research, or if you want, you can discuss with me and to give some ideas.
Any more question, please? Dear participant, either you can raise your hand or you can unmute your mic. There is one question in the chat box. I am working in the field of physical layer security for IoT. How to handle data generated from Wi-Fi module in physical layer key generation? Dear professor, this is the one question in the chat box.
Yes, working in IoT, it's very good, because you can collect data and transmit. I did not work in this field, but it's very easy to transmit this data to a center, and from there to obtain what data you want. So it's not a problem. IoT, it's everywhere. For smart house, it's exactly the same problem like in such a smart greenhouse. We need the data from such modules, and having data and having a model, we can predict the tendency of the weather and what to do more in the next hours, how to react, and so on. So only in general lines, I can respond in this problem because I am not involved in that physical layer, security, and so on. Of course, we need, specialists must develop all security possibilities just to protect data and so on.
Any more question, please? Okay, I think there is no more question. Dear Professor, thank you for your this wonderful session, and I extend my heartfelt gratitude to Professor Valentina A. Balas for gracing our 2-week faculty development program on data science and scientific computing with her invaluable presence and delivering an enlightening keynote address on artificial intelligence and machine learning, an introduction to data science and their various type of applications with examples. We are profoundly grateful to Professor Valentina A. Balas for her thought-provoking insight that have illuminated the intricate world of artificial intelligence and machine learning. Her profound expertise and deep knowledge in the field have undoubtedly enriched our understanding during this faculty development program. The clarity with which Professor Balas presented the foundation concept of data science has left an indelible mark on our academic pursuit. The interactive session following the keynote was an engaging exploration for the frontiers of AI, leaving us inspired and motivated. Professor Balas' dedication to the dissemination of knowledge has undoubtedly contributed to the success of our program. We express our gratitude for her generosity in sharing real-world examples and case studies, providing us with practical insight into the application of AI and machine learning. Thank you, dear Professor, for this valuable talk in this session. And I hope that all the participants got some insightful information valuable for all the participants. And we are presenting certificate of appreciation to Professor Valentina Balas for her acknowledged and honored for her exemplary contribution as the keynote speaker on the topic of artificial intelligence and machine learning during this 2-week faculty development program on data science and scientific computing. The program is jointly organized by Central University of Punjab, Poornima University, Jaipur, Nexus University, Baba Farid College, Bathinda, and Mathematic Thinking Foundation. So thank you very much to all the participants as well. And there are some queries from the participant. What about those participants who are not able to join this program due to network issues? So the thing is, as I in the beginning explained that the platform has all the things. Recording of each session will be available forever. Who are registered at this platform, and the content which we are presenting here will be uploaded, and some recorded lecture will also be provided to you, and all the informations we are sending on your registered email address, you must check your email address as well as your spam box. Sometimes you are not getting your email in inbox. So check your spam box also, as well as we are sharing all the information on your WhatsApp group. All the participant, I think, has joined the WhatsApp group. So please don't worry about the session. If due to network problem, you are not able to join, the recording of the session will be available in your account. You can cover all these things whenever you have successful access to this activity. So please keep in touch. And tomorrow we will start the session at the same time. The feedback form link is also has been shared in the chat box. You can submit feedback form for the today's session. If you have any question or any challenge to join the activity, you can contact us. WhatsApp number is given on the website, as well as we are sharing on your email address. Please feel free to ask any kind of challenge if you are facing due to related to this faculty development program. So thank you very much to all the participants for engaging and showing your interest in this wonderful activity. Thank you very much.
Thank you.
Thank you all.
Thank you all.
Thank you, Dr.